Welcome to 9.4, the electromagnetic spectrum. What we're looking at here is a remote control that uses infrared radiation, I suppose, to turn the channel away from one show to another. So you can see down here, that will send out an infrared signal, and that's why you have to point that light at the machine that you're looking for, as opposed to like a Bluetooth remote control or something that you kind of just point anywhere you like. So let's have a look at the different types of infrared electromagnetic radiation. So this is a very complicated diagram here, but it's really quite simple if you kind of break it down. This is down here, it's saying increasing wavelength. Let's look at the other way, decreasing wavelength. So this is a wavelength down here that is slowly, getting bigger and bigger, or smaller and smaller. So the wavelength is getting smaller and smaller as more and more energy is being put into it. Okay, so as you can see, the gigahertz are getting larger and larger, while the wavelength is getting smaller and smaller. So that makes sense, because the wave is getting faster and faster and faster and faster and faster and faster as it gets faster and faster. Okay, so down here we have radio waves, and these radio waves are like, this is emergency defense radio, this is AM band, this is FM band. Now we're starting to work into microwaves and radar, and it's still the same thing. It's still really light, I suppose. And as you move further and further down, we start to get an infrared radiation, which was the remote control. And just down here, we're starting to get into the visible spectrum. So just this little section here, this is everything we can possibly see. So while the frequency or the wavelength is of somewhere in here, that's everything we can see, from reds all the way down to purples. But then it speeds up even more, and we get into ultraviolet radiation, when the light is even faster and faster. As we go past ultraviolet, we can start getting into X-rays, and then gamma rays, if you remember what they are from the last chapter. Okay, so I don't want you to get all freaked out by this. It's just an increasing energy that causes a decrease in the wavelength, and these are the things that we can use these wavelengths for, from emergency defense radio, AM radio, all the way down through to visible light, ultraviolet light, X-rays, and gamma rays. And this is an application, I suppose. This is an X-ray of a broken, forearm. That's horrifying. So you can see the fracture here. The X-ray is going at such a fast wavelength that it's able to penetrate the skin, but it can't penetrate the bone very well. So although it goes all the way through the skin, it bounces off the bone a little bit, and that's why we can see the bone a bit better. In the same way we're talking about last time using sonar, you can use a very similar thing. It goes through the skin, but it bounces off the bone, so then you can detect, what it bounces off. Okay, so what is electromagnetic radiation? What is electromagnetic waves? All right, so let's break it up. EM, electro and magnetic. So there's two different types of energy, you might imagine, in there. So there's the electric energy. So the electric, you can imagine like static energy. This is hair being raised, and then there's magnetic energy, which is like in like a magnet. All right, but electromagnetic forces happen when you have an opposing up and down force of electricity. Okay, actually, let's say that's magnetic. Okay, so this one is a magnetic up and down kind of force that causes a wave through on a magnetic kind of scale, and the electric is these kind of back and forth electric forces as well. So it's when you get both an electric field and also a magnetic field, okay, working with each other, and in that way you tend to get these kind of up and down kind of waves. And that's what this is kind of showing us as well. Alright, so the electric fields are pulling up this way, and down that way, and down that way, and up that way. We tend to get this wave along here as well. and the magnetic fields are pulling up that way and that way. That causes all sorts of lovely waves. What's the difference between an electromagnetic wave and a sound wave? Well, first of all, sound waves are compression waves. Okay, they're the ones where there's areas of rarefaction and areas of compression, and that allows the energy to move across. Electromagnetic waves are the transverse waves that travel like a wave on a pond. Sound waves can travel through all solids, liquids and gases, but are unable to travel through a vacuum. Unless there's particles. If you remember, we need particles for a sound wave to travel through. Whereas an electromagnetic wave doesn't need any particles, so it can just travel through a vacuum itself. But, it does have trouble moving through some substances. The sound waves are also much slower. 330 meters per second to 350 meters per second, something like that. But electromagnetic wave moves at 3 billion, 300 billion, something like that, meters per second in the air. So it's much faster. Okay, so what I'd like you to do is I'd like you to go to chapter 9.4. I want you to copy all the blue words into Quizlet and then answer questions 1 to 6. Okay, thanks. I'll see you in class. Bye.